Section 2.7 is titled Rates, Ratios, and Proportions. Some vocabulary terms I want you to learn. Similar. When referring to figures, similar figures have the same shape, but not necessarily the same size. Corresponding sides are two sides of similar figures in the same relative position, and corresponding angles are two angles of similar figures in the same relative position. So if we say that triangles ABC and DEF are similar, we label them and we use this mark here to indicate similarity. And then it's also important to point out how we label, how we write ABC and DEF, because order matters. So the way they're written there indicates that angle A and angle D are similar. Angle B and angle E would be similar because they're both listed second, and angle C and angle F are also similar. It also follows the same with sides. The corresponding sides will also match up. So notice that AB is written first and so is DE. So sides AB and DE would be similar. And you can work your way around the triangle and say the same thing about all three sides. So let's look at an example where we're supposed to find the length of the missing side. We're told that triangles RST and BCD are similar, and we're given the side lengths of three sides, and we're trying to find the fourth side length. It's labeled X. It's BC from triangle BCD. So what we first want to make sure when we're setting up our proportion is that we're using the right pieces in the correct places. So for example, if I look at side RT and I know that it's 5 feet long, I can put 5 on top and I can put 8 from the other portion of the same triangle on the bottom. But when I go over to the other triangle, the part that's similar, the side that's corresponding to wherever the 5 came from, is what I also have to put on top. So if we look here, RT is 5. RT, that's the first and the last letters. So B and D, the first and the last letters, would be the corresponding sides. So we would put 12 on top and the X on the bottom. That's one way to set up the proportion. Use both pieces from the first triangle, both pieces from the second triangle, make sure that the corresponding parts are on top and the corresponding parts are on the bottom. Another way to set up this problem is using the 5 from the first triangle and the 12 from the second triangle, because those are the corresponding parts. So you can put the corresponding parts on top of one another. You just have to make sure that you're using the parts from the same triangles on top. So I need to put the 8 on top and the X on bottom. So we still need to solve this. Either one can be solved, you'll get the same answer. 5x equals 96. Divide both sides by 5. 96 is not divisible by 5. It also does not reduce. You can give me a fraction here, but I would just leave it as 96 over 5, and we should put a label of feet. Okay, let's look at another example. We have triangles MNP and STU are similar, and we're supposed to find the length of the missing side. So we're given MN and we're given NP from the first triangle. We are given ST and asked to find TU. So if we start with MN, we can see that side MN is corresponding to ST, so 6 over 4. We can then see that NP is similar to TU, so 14 over X. Remember, you need to be picking the same parts on top, the same triangle on top. Both of those numbers come from this triangle on top, and both of the numbers on the bottom come from the triangle on the right. So we get 6x equals 56. And we divide both sides by 6. 56 is not divisible by 6, but this fraction does reduce. 56 and 6 are both divisible by 2, so we get 28 over 3 centimeters. Here's another example. This one's a little tricky, but we have triangle ABC. Please note where that triangle is. That's the large triangle on the outside. similar to triangle AED, the smaller triangle on the inside at the top. So we're to find the length of the missing side. That's AC, and that's from the large triangle. So these are both right triangles. The small triangle is right triangle, and so is the large triangle. So we see that we have the bases of the triangles. So I can do 8 over 12 equals 9 over x. Or what's the other proportion you could write? Instead of saying 8 over 12, we could say 8 over 9. That's both parts of the small triangle over 12 over x, both parts of the large triangle. Either one can be solved, but we get 8x equals 12 times 9. I don't know that one off the top of my head, and I don't feel like thinking. It's 108. Divide both sides by 8. And if you reduce it, you get 27 over 2, or 13 and a half. And there are no units here. Let's look at an example where we need to set up our own proportion. We have a house that casts a 56-foot shadow. A girl standing nearby casts a 7.2-foot shadow. Her height is 5.4. What is the height of the house? So we have 3 pieces of information. We have the shadow of the house, we have the shadow of the girl, we have the height of the girl, and we have the height of the house. That's the 4th piece of information that we actually don't know. But when we set up this proportion, we just need to make sure that we have the right pieces in the right place. And remember, they kind of match. So either on the tops of the fractions, we need the shadows, and on the bottoms, we need the actual heights, or on the left fraction, we need shadows, and on the right fraction, we need heights. So you can really pick which way you want to set this up. See if you can pause it here, set it up, and see if you get if you set it up correctly. So if we do the shadow of the house, that's 56 feet over the shadow of the girl, which is 7.2. We're going to set that equal to, notice I put the shadow of the house on first, so I have to put the height of the house on top over here. I don't know the height of the house. The height of the girl is 5.4. So I have the shadow of the house and the shadow of, and the height of the house on top. And I have the shadow of the girl and the height of the girl on the bottom. Another way you could set this up, you could have the shadow of the house over the height of the house, and the shadow of the girl over the height of the girl. So either one of these is correct. So I'll just solve the one on the left. 7.2x, 56 times 5.4 is 302.4. Divide both sides by 7.2. And we get x is 42 feet. So the house is 42 feet tall. In class, we're going to work on worksheet 2.7. We'll be dealing with similar triangles and setting up proportions.